I just wanted to give mention to one shape that comes up in most parametric curve sections, including ours, and this is called a cycloid. I don't find that this is actually a very interesting shape, but I just want you to know what it is because it does tend to come up in the examples. So what a cycloid is if you imagine that I have a wheel, which I've drawn here as a green circle, and we start it with a purple dot called P on the origin. Now imagine that I simply roll the wheel. I simply roll the wheel to the right, and I roll it so that it makes one revolution every 2 pi seconds. So let's say that I'm measuring time in seconds, and every 2 pi seconds it makes one revolution. It's sort of convenient because 2 pi is the number of radians in exactly one circle. So what would happen is this purple dot, if I simply followed the position of the purple dot as the wheel rolls, keep in mind the purple dot keeps traveling around the wheel. So when the wheel rolls a little bit, the purple dot's not going to be at the beginning anymore. It's going to be there. It's going to be there. It's going to be there. But the reason that the dot isn't moving exactly where I show it is that the wheel is rolling forward. So the path actually traced out by a by a circle by this dot as the circle rolls is called a cycloid, and it has this sort of shape to it. It's not the sine wave. It just repeatedly forms arches like this. This is the position that you'd see the dot in if you followed it as the wheel rolls to the right. So the thing to understand is that the wheel is rolling to the right at a rate of at. In other words, for every unit of time, the wheel has moved for every second the wheel moves a seconds to the right. But if you can imagine this purple dot, it's being kicked a little bit to the left even as the wheel rolls to the right. That's going to follow a trigonometric function. So the x position of the dot is going to be at. In other words, that's the position of the center of the circle as it rolls to the right. And then plus, oops, sorry, this is actually going to be, no, it is minus, I'm sorry. It's at minus a sine of t. And then y, we can see is that the vertical position of the center doesn't move at all, so that's just going to be a. But we start out with the dot being at the very bottom, and then as the wheel rolls, it goes up to the top and down to the bottom again. Well, if you think about what trigonometric function you know that works that way, there's the cosine function. So what we're doing is we're subtracting a cosine t. Um, from the horizontal position. So that means that at the beginning, when t is 0, this is going to be a minus a, or 0, giving us a y position exactly where you see it down there. So that's where, when we simplify it, that's where we get these expressions. So it's just, I'm not going to do an example with a cycloid. It's just useful to know what shape it is. So the concept is you're tracing the curve that would be followed as this purple point moves with the wheel as the wheel rolls to the right. These two archy things, arches, that's what they're called. They're called arches of a cycloid, that just keep repeating. And by the way, this is a point. This is not a smooth curve at this point. This is going to be, this would be a sharp point that it comes to and then starts over again. This shape, the arches, are called a cycloid. It's not the wheel that's called a cycloid, it's the arches. So just the same as how this shape is called a parabola, this shape is called a cycloid, and it's traced out by the wheel.